side that says alpha rocks. Okay? What are you going to do? Better faster. You absolutely are going to factor. So here we go. Let's see. 2x, x, 3y. Let's try that. How does that look? Nope, that's not right. How about that? Is that better?
That'd be yeah, plus 3 minus 2.
No.
Positive end. Positive end.
This is positive 4. That's negative 3. Okay. Now, nothing cancels, so that means that where it says find a hole, there won't be one.
Yep.
Because in order to have a hole, you have to be able to cancel, and obviously that's good. Alright, so let's fill in some more things. What do I have? I have a vertical asymptote at x equals negative 1. What else do I have? I do not have a horizontal asymptote. I have what's called an end behavior asymptote. It is a slant asymptote. How come this one is slant?
Because the top and
The top has 2x squared and the bottom has only x. So there's going to be a slant asymptote. Anybody remember how to find it?
just do the division.
The division. So back to the original problem. I'm going to do the division. And when I'm talking about a slant asymptote, I don't care about the remainder. The remainder is not part of the conversation. What is my slant asymptote? Y equals 2x minus 1. So I'm going to go ahead and sketch that in here. That is a line with a y-intercept at negative 1 and a slope of 2. So there is my y equals 2x minus 1 line. All right, what else do I have? What does the numerator tell me? I have an x-intercept at negative 2 and another one at 3/2. The numerator gives us our x-intercepts. The zeros of the numerator give us our x-intercepts. Alright, how do I find the y-intercept? Now, this y-intercept goes with my asymptote, not with my curve. How do I find my y-asymptote, my y-intercept? Plug in 0 to the problem, and I can do that in the original or the factor. I think I get negative 6. Shoot, it's down here. So I have 1 through 5 are filled in. So now I need to draw my picture. Can you envision it? It follows its asymptotes. So that that one's gonna do that. And this one over here is gonna do that. So we're used to seeing a shape that's more like this. That's the same shape, it's just fatter. And on the diagonal instead of straight up and down. All right, now we're gonna answer some questions. Question number 6 says, as I follow my curve to the right, what is happening to it? The farther right I go, the higher it gets. So what's the answer to number 6? Infinity. Yep. The farther I go to the right, the higher I am going. This is going up, up, up along that line. So she's heading right up into the ceiling. Now 7 is a little bit tricky, but it's actually super simple. It says, let x approach 0. Now, this is where x is 0, right? Right here? That's a point. When you find the limit at a point, it's just the y coordinate. So the answer to number 7 is -6. The closer x gets to 0, the closer y gets to -6. Now, I want to make a point, because this said getting close to 0 from the right side. It doesn't make any difference which side you come at it from. If it's a point, doesn't matter which side you're coming at it. If it's a point, your limit is the y coordinate, period. Okay, so this guy right here has no impact in this problem because 0 is a point. It isn't an asymptote. An asymptote would matter. Am I coming from the left or the right? But when it's a point, it doesn't matter. So the answer to both of those would be -6. All right, now 8 is different because 8 is an asymptote. Would you agree? And this says, I am coming toward my asymptote from the left. What is happening as I get closer to the asymptote on the left side over here? Going up. So the answer to number 8 is positive infinity. Because we're going up. Number 9 says, what happens as we go to the left? Well, tell me, what happens as I draw to the left? Negative infinity. Negative infinity. Number 10 says, come towards your asymptote, but come in this way. Come in this way. What is happening as I come toward the asymptote on the right side? What's the curve doing? Going down. So the answer to number 10 is negative infinity. Because the curve is going down. Now 11 and 12 are kind of weird questions. Here is where x is 3. Is there anything special happening to the curve at x equals 3? Like a dot or an asymptote or anything like that? No. Is it where x is 3 just going to be a point? So 11 and 12 are going to have the same answer because it doesn't matter which side you come at a point. But what is the answer going to be? What am I going to have to figure out? what is the y coordinate? The answer is the y coordinate. And how am I gonna find the y coordinate? That's just some random point on the curve. How do I find the y coordinate? Plug 3 in. So, and I can do it anywhere I want. If I plug 3 in, I'm gonna get 3 times 5 over 4. I got 15 fourths if I plugged in 3 correctly. That would be 3, that would be 5. Yeah. So I got 15 fourths. So the answer to 11 and 12 is 15 fourths. Because 3 is not an asymptote, it's a point. And when you come at a point, both ways, you're coming to the same place. All right, let's turn it over and try another one. All right, I'm gonna give you a couple of minutes, you and your partner, see how far you can get. Let's start, go together and make sure we get it factored correctly. What are our factors gonna be? -3 plus 1? I agree with that. All right, see how many of those 12 blanks you can fill in. does your picture match mine? If your picture matches mine, then you should be answering the other questions then, 6 through 12. Any question about the picture? Yep, Erica?
I need help finding this one.
The division. Synthetic division. Divide the problem. The problem is the division problem.
To find the y-intercept, you put 0 in for x on the
Every x.
every x.
Every x. All right, number 6. What's happening as we head off the page to the right? Follow your curve to the right. What's happening?
Going higher.
Going higher, which means the answer is positive infinity. Yep, so number 6 is positive infinity. Number 7. Now, x is 0. Isn't this for x is 0 right here? So what's the limit? No matter what, the limit as x approaches 0 is 3x. 1.5. That is number 7. Number 8. Now I have an asymptote at 2. This one asks me, come in from the left. Here's your asymptote. Coming from the left, what's happening to my curve? Positive infinity. Skip down to 10. What happens from the left or from the right side? Coming in from the positive side, the answer is negative infinity. Number 10 is negative infinity. Now, what's 9? 9 says, what happens as you go to the left? Well, just keep going. What's my arrow doing here? Going down, negative infinity. And then 11 and 12 revolve around x being 3. And isn't there a point at 3?
Yes.
So the limit from the left and the right are the same, and it's the y coordinate. So the answer to 11 and 12 is 0. Because the point is at 3, 0. The limit values are the y values. What are the y values as x is doing whatever the problem says? Okay? Tomorrow we quiz.
On just this.
One problem. You have to look just like this. One problem.
Just for can you explain the end of major asymptote?
That's your sign asymptote.
Okay. So this y equals x.
Yep. All right, now we need to get our notes out. And we're going to do some equations and some word problems. Alright, we're gonna solve this equation. We're on page 29 of our notes, I think. And we are going to solve this equation. So we're not graphing it. Our answer is going to be x equals something. We're solving it. So how would you suggest we begin this? I would multiply x by everything. And when I do that, I would be left with this. Would you agree with that? Multiply by x. Alright, now what?
Subtract 4 over.
Move the 4 over. And when I move it, I'm going to put it in the middle here because then my problem's like in the right order. Okay? Is that alright with everybody? And then what am I going to do? Factor it. Or if I happen to hit one that didn't factor, I could always use my quadratic formula. Put the swing factors, and it looks like x is 3 or 1. Now, one thing to keep in mind as you're doing these problems, especially as they get harder, is that from the beginning, you generally have what are known as excluded values. In this problem, x couldn't be 0. Now, it didn't turn out to be 0, so I don't have to worry about it. But can you tell from the original that before you even solve it, you know x can't be 0, right? Because you can't have a 0 in the denominator. So it's not a bad idea to keep track of those, because sometimes you might get one. All right, let's look at number 2. In this one, x can't be 4. Would you agree with that? All right, now, how do you want to solve it? There are different strategies. How do you want to do it?
X can't equal 4 because you can't have x equal 0.
What happens if x is 4?
Oh, okay. The denominator is 0.
And you can't have 0 in the denominator ever, right?
Yeah.
Okay, so what do I do to actually solve this thing? I know what x can't be, all right? Let's talk about what x is. I can do x minus 4. Just like here you did x. Here you can do x minus 4. Does that make sense to everybody? Perfectly allowed. So x squared minus 4x plus 1 equals 0. Oh, cutie. We got a quadratic that does not factor. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So 4 plus or minus the square root of 12. And the square root of 12 is 2 root 3. And then I notice that I can cancel only because I can cancel from all 3. So triangle. So my actual answer is finally 2 plus or minus root 3. What do you think? You okay with that? All right, look at the next one. When you behold, it factors into x minus 1, x minus 3, which makes our life so much easier. Now, some of you will do a lot of this in your head, but I really need, particularly those of you that struggle with arithmetic so much, I really need you to understand what's going on here. In order to solve this problem, I need all the denominators to be the same. So I am going to give this fraction an x minus 3. And this fraction is going to get an x minus 1. And that fraction doesn't need anything because it already has both.
Oh, we've done it
Once,
before.
of course you've done this before.
Okay.
Once the denominators are all the same, then you can disregard them and simply solve the numerator.
That's what we like to see.
Now, some of you will get that line a different way, and I'm okay with it, as long as you get this line. Behind the scenes, what's happening is, we're making the denominators match, and then we're dropping them. And that's what we have left. Before I get into this too much more, x cannot be 1, and x cannot be 3. Do you understand that? Right off the bat, I know that. I gotta pay attention to that. All right, now how do I solve this? I'm gonna distribute and get 0. So I think this is going left way.
Yes.
This one does factor, but if you don't see that, you can do what we did over there, quadratic, use the quadratic formula. But this one does factor. But again, if you struggle with factoring with a real coefficient, you can always use your quadratic formula. So what does x equal? X either equals negative 1/2 or 3. But wait a minute,
We can't equal
it can't equal 3, so the only answer to the problem is,
Mic drop.
alright, go ahead, little ones back here, at 30 back here. Have a good watch. You haven't eaten too many reasons. Puking downstairs.